We are Soshaks, and our project is titled AI for Sustainable Metallurgy. Our platform addresses the urgent need for sustainability in the metal and mining sector, particularly for metals like aluminum, copper. Currently, life cycle assessments are manual, slow, and often incomplete due to missing data. We have built an AI/ML powered system that intelligently fills these data gaps, generates accurate environmental insights, and presents them in an easy to understand dashboard. Our solution not only improves efficiency but also supports industries in making eco-friendly and cost-effective decisions by recommending actionable steps. What makes it unique? It's the first AI-driven LCA tool tailored for metals, combines circularity, sustainability, and cycling insights in one dashboard. Helps industry reduce carbon footprint, comply with regulations, and move toward net zero goals. Promotes material use by comparing virgins versus recycled options instantly. I will be giving the detailed explanation for AI for sustainable metallurgy. First, AI powered web platform solving sustainability challenges in metal sectors like aluminum, copper, and etc. Traditional LCAs are manual, costly, and data deficient. Automates LCA workflow using intelligent algorithms and also reduces human error, time, and effort. Second, how to address the problem. It uses AI/ML to fill incomplete LCA datasets, convert raw data into interactive visual dashboards, supports real-time decision making with comparisons, for example, virgin versus recycled metals, suggests optimized sustainability strategies with cost and emission trade-offs. Third, innovation and uniqueness. First, AI LCA tool designed specially for metals combines circular economy plus sustainability in one unified system, generates recommendations, not just reports, supports regularity, compliance, carbon reduction, and green certifications. AIDS industries in aligning with EGS, which is environment, social, and governance goals.
First, we begin with the start stage. Here, the process is initiated and the workflow kicks off. From the start, we move to the user input. In this step, user provides their data through requirement, forms, and quality assurance check. The system also verifies the data entry to make sure everything is correct. Next, we go to user feedback. Here, users share their experience through rating, comments, suggestions, feature requests, and improvement tracking. This feedback loops helps us to refine the system. After feedback, we move to the first export and share stage. At this point, the system allows exporting data, sharing results, syncing with the cloud, and providing API access. From there, we go to data validations. The system generates graphs, charts, suggestions, and automated reports. This ensures that the data is clean, accurate, and reliable. After validation, we again have an export and share step. Here, validated results can be exported in different forms like charts, shared via cloud, or integrated using APIs. Next, we move to visualization. This is where data is represented in an easy to understand format. Rating, security checks, charts, graphs, and heat map sequencing. After visualization, the flow goes into AI processing. This step uses advanced techniques like machine learning, natural language processing, outlier detection, and predictive analytics to extract deep insights from the data. Finally, we reach recommendations. Based on AI analysis, the system provides useful outputs like graphs, reports, suggestion, and error detection. These recommendations helps in making better decisions. Now that we have explained the powerful AI architecture driving our solution, let's look at how we translate that technology into a simple and actionable tool for the end user. The first thing a user sees are the four key metrics at the top. We provide an instant overview of their entire sustainability portfolio, tracking their average carbon footprint, our unique circularity score, and tangible energy savings. This transforms complex data into clear, immediate, and understandable KPIs. Below, the recent project section act as the user's command center. They can manage multiple LCAs, track their status from draft to progress to completed, and instantly see the core results like the carbon footprint for their aluminium can production. This makes comparing projects and making informed decisions incredibly straightforward. On the right, features like the quick start button guide new users to begin their first assessment effortlessly, driving adoption. Meanwhile, the updates and news panel ensures that our users are always informed about crucial compliance changes and enhancements to our AI models, building trust and keeping the tool relevant. I'll now walk you through the core user journey of our platform, creating a new lifecycle assessment. We have decided this as simple, guided 5-step process that makes a complete task feel effortless and intuitive. Everything starts here at step 1. We ask the user for the foundational information about their project, the project name, a brief description, and the metal type. The goal here is to provide a frictionless start. The interface is clean and familiar, ensuring the user can begin their assessment immediately without any learning curve. The step sets the scope and context for the entire analysis that follows. Next, in steps 2, we capture one of the most critical factors for sustainability: material inputs. The user inputs the amount of virgin materials and, crucially, the percentage of recycled content. Here, we introduce our first smart assistant feature. Now, the AI recommendation box. Our platform isn't just a passive form, it's an active guide. Based on the metal type selected in the previous step, our tool provides a helpful benchmark for typically recycled content. This immediate empowers the user with industry knowledge and encourages more sustainable choices from the outset. Next, in step 2, we capture one of the most critical factors for sustainability: material inputs. The user enter the amount of virgin material and, crucially, the percentage of recycled content. Here, we introduce our first smart assistant feature. Notice the AI recommendation box. Our platform isn't just a passive form, it's an active guide based on the material type selected in the previous step. Our tools provide a helpful benchmark for typical recycled content. This immediately empowers the user with industry knowledge and encourages more sustainable choices from the outset. Step 3 focuses on energy and resources. We have distilled what can be a very complex set of variables into the two most impactful metrics: energy consumption in megawatt hours and water usage in cubic meters. By providing clear, standardized field, we eliminate guesswork and ensure the data we collect is accurate and ready for precise impact calculations. In step 4, we account for the logistical footprint by asking the average transportation distance. This ensures that the environmental impact of the supply chain is included in the final analysis, providing a more holistic and accurate life cycle assessment. And finally, we have arrived at step 5. This is the most innovative and crucial part of our solution, where we directly solve the industry's biggest challenge: incomplete data. First, our system performs a data completeness analysis. It transparently shows the user the status of all the data they have provided. As you can see, it has identified that the transportation data is missing. Instead of hitting a dead end, the user is presented with our AI gap filling feature. The system explicitly states that it has identified missing data points and can estimate them. The user remains in a complete control. With a single click of the Enable AI Estimation button, our backend models analyze the project's content and fill the gap with a reliable benchmark based value. This single feature turned a major red block that could halt a project for weeks into a seamless, transparent, and simple action, ensuring a comprehensive LCA is always achievable. By guiding the user this assistive, intelligent workflow, we have transformed a daunting month-long process into a simple task that can be completed in minutes. Here we have the LCA result dashboard. It shows key indicators like carbon footprint, water usage, energy consumption, and waste. You'll notice numbers here, but these are just placeholders to demonstrate how result would look. We also have a material flow analysis section that breaks down virgin aluminium, recycled content, and process efficiency. And finally, the impact categories highlight areas like climate change, resource depletion, water usage, and toxicity. Overall, this screen is just to showcase how results will be presented visually to make sustainability insights clear and easy to understand. This dashboard provides three key views of the life cycle assessment result. The circularity view shows how materials are recycled, reused, and recovered with an interactive diagram representing material loops and overall circular economic preference. The comparison view lets us evaluate different production scenarios side by side, such as current processes, higher recycled content, or fully virgin materials, highlighting impacts on carbon, water, energy, and cost. The recommendation view suggests high impact improvement, including increased recycled content, optimizing transport, and adding energy recovery systems, with prioritized implementation timelines: short, medium, long. All numbers shown are sample placeholders. This section is where user can generate, manage and download LCA reports. On the left we have the report configuration panel where we can select the projects, choose report type, output format and decide which section to include like executive summary, methodology, results or recommendation. On the right we see the generated report list with option to preview, download or share. Each report shows detailed like project name, date, format, and status. At the bottom, there are report templates for different needs, such as regularity compliance, executive summary for management, public disclosure for stakeholders, or technical analysis for R&D teams. All reports are automatically compliant with ISO 14040 standards, ensuring they meet international guidelines. The settings section allows user to manage their account and platform preference. Under profile, user can update personal details like name, email, organization, and role. In preference, they can customize the platform by choosing default units, enabling autosave AI recommendation and visual settings. The integration tab connects the tool with ERP systems, environmental databases, carbon accounting platforms, and also provides API key management. Notifications let user control how they receive updates, whether it's project alerts, data warnings, or weekly reports via email or in-app. And finally, security ensures data protection with password updates, two-factor authentication, data export, and even account deletion. So overall, the settings section gives full control over personalization, connecting, and security.
In the technology stack, for the front-end UI UX, we'll be using React to build the interactive user interface such as visual dashboards for displaying emission data, the input forms of LCA parameters, and the comparison charts. And second, we will be using JavaScript to power the interactivity of the React components like updating graphs in real time when a user changes a scenario or validating user inputs. Third, we'll be using Tailwind CSS to quickly design and style a clean model and user-friendly interface for your dashboard and reports. And fourth, we'll be using Beat, a development tool that helps build and run your React application very quickly, speeding up the development process. And for the backend, we'll be using Python, the core language of your AI/ML models. It will be used for data processing, predicting missing data points, and running the complex LCA calculations. And second, we'll be using Django, the web framework that organizes your Python code. It handles user authentication, manages the overall application logic, and connects the further frontend to the database. Third, we're using REST API, acts as a communication bridge. It allows your React frontend to send data like user inputs to the Python backend for processing and receive the results like LCA scores to display the user. And third, for the database and hosting, we'll be using MongoDB. It is used for storing large, unstructured, or complex data such as diverse datasets from LCA database. For example, equivalent material flows and outputs of your AI models. And second, we will be using MySQL, used for storing structured data that fits neatly into tables like your user account information, saved project details, and generated reports.
Myself, Aisha Piwala, I will be explaining about the feasibility and viability of our solution. There is a strong market demand due to the global push for sustainability. Industries feel pressures from investors, consumers, and regulators, and compliance with ECG standard is mandatory. Our platform provides a clear and efficient pathway to achieve compliance quickly and reliably. However, there are some challenges companies may be cautious about trusting AI-driven data, and they often have fragmented data spread across multiple systems. Additionally, environmental regulations are constantly changing, and integrating with diverse legacy systems can be complex. To address this, we have a strategic approach. First, we build trust through validation, onboarding, and continuous support. Second, we ensure credibility via strategic partnership with industries and research institutions. Third, we offer a robust API for smooth system integration. Finally, we keep our platform agile, allowing quick adaptation to regulatory changes. With these measures, our solution is both technically feasible and practically viable, ready to help industries achieve sustainability while remaining efficient and compliant. Impact. Our platform dramatically accelerates sustainability decision making, reducing the time from months to just 1 minute. It also simplifies complex ECG reporting, turning long, difficult to read report into easy to understand insight. By providing verifiable data-driven green credential, it boosts global competitiveness, helping companies showcase their sustainability achievement. Additionally, it reduces operational costs by optimizing resource use and promoting recycling. Benefits. Our solution also drive the adoption of a circular economy, encouraging reuse and recycling of material in a core industrial sector. It strengthens the Make in India initiative by modernizing industries with sustainable practices. By introducing AI and technological driven solutions, it fosters innovation in traditional heavy industries, creating skill job opportunities. Most importantly, it significantly reduces India's carbon footprint, contributing to a cleaner and more sustainable future. In short, our platform not only addresses the industrial challenges but also creates long term environmental, economic, and national benefits. On this slide, we are highlighting the research and references that guided the development of our solution. We reviewed a recent research paper on sustainability and circularity in the metal industries, including studies on aluminium recycling, barrier on circularity, and the integration of LCA with circularity assessment. This paper helped us understand the challenges and the gap that currently exists in the industry. Additionally, we refer to reputable databases and industry sources like the International Aluminium Institute, Nexus Open SCA, and EcoInvent to obtain accurate SCA data and environmental metrics. This ensures that our AI driven platform is data backed, reliable, and aligned with industry standard. Overall, our solution is not just based on innovation but is grounded in verified research and credible industry data, making it both practical and implementable in real world scenarios. In short, our AI driven LCA platform is faster, smarter, cost effective, and actionable, helping industries comply with ECD standards while promoting sustainability and circularity at both national and global levels. Thank you.